For a few minutes, this is going to feel very random, but you will eventually see the connection with complex numbers and vectors. So first, let's talk about a complex number. Give you 30 seconds. Turn to your neighbor. What's a complex number? Okay. Somebody from Pod 4. What is a complex number? Something to do with imaginary numbers. You are correct. This is a complex number. It is in the form a plus bi. A is the real part. B is the imaginary part. Okay, we talked about complex numbers way back in chapter 2, maybe. When we talked about roots, I think it was way back in chapter 2. So it's been a while. Okay? We can represent these graphically. Now, if we have a number line, we can plot real numbers. Okay? Well, these complex numbers have real and imaginary parts to it. So we can't just plot these numbers on a real number line. Okay? What we have to do is we have to take the real number line and connect it with an imaginary axis, and now this is what we call the complex plane. Okay? This is not the same coordinate plane that we plot xy coordinates on. This is the complex plane that we use to represent complex numbers. Okay? So if we wanted to graph the number 2 plus 3i, we would move 2 in the positive direction on the real axis and 3 in the positive direction on the imaginary axis. There is 2 plus 3i. If I wanted to graph 5 minus I, we would move 5 on the real axis in the positive direction, and then 1 on the imaginary axis, but in the negative direction. Where would we place the number negative 3i? Michaela? Down 3 on the imaginary axis. Very good. How about if we were to graph the number 2? 2 on the real axis. Okay. Why does it matter where we graph these? Well, I want to talk about the absolute value of a number for a moment. So, turn to your neighbor. I want you to discuss what the absolute value of negative 5 and the absolute value of 4. What are those values and what do they represent? 30 seconds, go. Okay, pod 1. That is you. What do you say?
5, 4, and they're the decimal from 0.
5, 4, and they represent the distance from 0. How do you think about that? I don't think I could have said it any better. The absolute value is the distance from 0. So let's talk about the absolute value of a complex number. Okay? So these, we think of the distance from 0 on the number line. On the complex plane, we need to think about the distance from
The real axis.
the origin. Okay, so it's still the distance from 0, but the origin is going to be our 0. Okay. So let's consider this number. How might we find that distance from 0, or the origin? Say it loud. The Pythagorean theorem, right? If I'm looking for this distance, we know that this distance is 3, and this distance is 4. And we have a right triangle. Okay? So the absolute value of 3 plus 4i is just going to be the square root of 3 squared plus 4 squared. Now, the I does not go in there with the Pythagorean theorem. There's a distance of 4 from the real axis, so we plug in 4, not 4i. Okay? So what is our distance from 0? Square root of 25, which is 5. Okay? What does this look a lot like? This looks a lot like the magnitude of a vector. Say it louder. Okay, you can imagine magnitude, the length of a vector, absolute value of a vector. Okay, they represent similar things, but for two different pieces of information. Okay. So you practice for me. Find the absolute value of this number, please. Maddie, what do you have?
Radical 29.
You agree with Maddie's radical 29. Excellent. All right. Let's move on to the trig form of a complex number. Okay? Now, we're going to break this apart a little bit. By the end of this slide, I will tell you how to write the complex form, or the trig form of a complex number. Okay, but let's think about this picture. Okay? We write the number as a plus bi. Right? Here I have a picture. When we plot a plus bi, we travel a on the real axis, and then we travel b along the imaginary axis. Okay? We get a nice angle. I've labeled it as theta. We can call the absolute value r. Okay, kind of looks like a radius if you want to think about it that way. Okay? So first question, how would we determine what that angle is? Okay? If we know A and B, then the tangent of theta is B over A. Does that look familiar? No? Yeah? A little bit, right? Okay? Let's talk about A, the real part of this. How do we relate A, theta, and R together?
R times the cosine of theta.
Okay, I'm gonna take one step back. The cosine of theta would be adjacent over hypotenuse. And so you just said, all right, that means A is the same thing as R times the cosine of theta. Okay? Where R is representing what? Okay, and what about as far as A plus BI? R is the absolute value. R is the distance from 0. Okay? What about B? What will we use? The sine of theta is opposite over hypotenuse, or in other words, R times the sine of theta is B. Okay? So we can write our real part as our cosine theta. We can write our imaginary part as our sine theta. And so the trig form of a complex number looks like this. Instead of A plus BI, we could write R cosine theta plus I R sine theta. Now, when we write it in trig form, the I is going to come before the B. When it's in standard form, that's what we call A plus BI. The I is going to come after the B. Okay? But you don't really want that I to be attached to your angle, so we like to write it in front of the sign. I know it kind of looks awkward, but it keeps things less messy. Okay? You are going to see your book write it like this. R times cosine theta plus I sine theta. Since both terms have the R multiplied to it, you will see this more often than what I have typed here in black. Okay, so you may want to get used to just seeing that R factored out. I'll accept either way. All right, so you're going to have to do two things for me. You're going to have to be able to go from standard form to trig form, and vice versa, trig form to standard form. Okay, so let's first try standard form to trig form. So here's our standard form number, -5 plus 6i. Okay. So to write this in trig form, we need two things. We need to know its distance from 0, and we need to know its angle. All right? So first, I'm going to plot this so I can imagine which quadrant it is in. Okay? There's our complex number. Okay? First, let's find the distance from 0. We like to label that as r. So we'll take the square root of -5 squared plus 6 squared. So what is r? What is r? Yes. Square root of 61. Okay. Now we need the angle. All right. Just like in vectors, the tangent of theta is b over a. So in your calculators, what's the inverse tangent of 6 over 5?
Do you need the direction angle or?
So basically what we're finding is that direction angle. That's the equivalent of what we'd be finding in terms of
Do we
vectors.
need to add it to 180?
Okay, so this is going to give you a reference angle, right? What does it give you? Negative 50.
0.19.
Okay, so let's just forget about the negative for a second. 50.19, okay? This is your R, okay? 50.19 is describing this angle right here. We want this angle here. How do we find it? Okay? 180 minus 50.19, and that gives us,
129.
okay? So whichever quadrant your complex number falls in, your angle needs to match that, just like with vectors. Okay? So to write this in trig form, we're going to write R cosine theta plus I R sine theta. Okay? It is also just fine if you want to factor out the R and write R times the quantity, cosine theta plus I sine theta. Okay? Whichever one you write, I will accept. Basically, we're taking A plus BI and we're breaking up A and B into the magnitude of direction, kind of, if we relate it back to vectors. Okay? R is the distance from 0. Theta is the angle that it's making. Let's go the other way. What if I gave you this number in trig form and I asked you for the number in standard form? What would we have to do here?
3 times the cosine.
Okay, let's figure out what these values actually are, right? Let's see, Matthew, what's the cosine of 315? It's a unit circle.
Would it be?
It's not one
Okay,
half.
then it's not over two.
It is not that either.
Okay, then it's that it's 2 over 2.
There you go.
Woo! Finally got it. Okay, no. That's okay, we got there.
Okay. Cassie, how about sine of 315? Same thing, just negative. Great. So in standard form, this number is 3 radical 2 over 2 minus 3 radical 2 over 2i. Our cosine theta, our sine theta. Yes.
So like on the test, if the value is like on the unit circle, then we should write it in terms of radicals instead of
Yes.
the decimal.
Yes. Anytime you have an angle that is a unit circle angle, I want exact. Okay? Now, I do want to tell you one shortcut. You will see some shorthand for this. Some of you may think, oh my gosh, that is so much to write out. Kind of is. There's an abbreviation of R, C, I, S, the angle. R, C, I, S, theta. That just stands for R cosine theta plus R I sine theta. Okay, that's just a way to shorthand it. If you'd like to use that notation, go for it. If you don't like it, that's fine. You just may see it. Okay, so I just want to warn you what it is. Okay. Now, when we had complex numbers, let's say let's say you had 2 minus I, and you had to multiply it by 4 plus I. What would you have to do? Well, not yet. You'd have to FOIL, right? What about if you had to divide them? You'd have to multiply by the conjugate of the denominator, and then FOIL your numerator and denominator, and then simplify, blah, blah, blah. Okay? Sometimes kind of a pain in the rear, right? Well, if your numbers are in trig form, multiplication and division are quite nice. So here are the two numbers that we're going to multiply and divide, just in general. Okay, so if you want to write these down, you can. So we have Z1 and Z2. So everything's labeled in subscripts 1 and 2. When we multiply numbers, we multiply the R's and add the angles. And we're done. So when we multiply two complex trig numbers, we multiply their R's and we add their angles together. Let's use the same logic. What do you think the quotient is going to be like? Subtract the angles and divide the R's. Okay. Now, when we write the trig form of complex numbers, we do want our angle to be between 0 and 360 or 0 and 2 pi. Okay, depending if we're in radians or degrees. So if we take the product or the quotient and our angle is not between 0 and 360, then we're going to have to use our knowledge of coterminal angles to rewrite our answer. Okay? So if our angle is above 360, we can subtract 360 until we have an angle that fits that description. If it's a negative number, because that's a possibility, then we wouldn't have to add 360 until we have a number that fits that description. Okay? So make sure you think about your answer. Is this the way that it should look? And then you can adjust it if need be. Sometimes you won't have to adjust at all. Sometimes you will. Okay. So the two examples I have here, I did write them in that shorthand. Okay, so you can see what it looks like. Okay. All this means is 4 times cosine 120 plus I sine 120 times 6 times cosine 315 plus I sine 315. Okay? If you don't like the shorthand, just rewrite them to this. Otherwise, you can use the shorthand. Okay? What do we do with 4 and 6? We multiply them. What do we do with 120 and 315? We add them. We add them to get 435. Is that the answer that we want? No, this is too big of an angle. So let's use our knowledge of coterminal angles. We need to rotate backwards 360. What is it? 75. So this is the answer that I want. If you don't like the shorthand, then write it as 24 cosine 75 plus I 24 sine 75. Matthew's question answer. Okay. Everyone okay with how we got 75? Okay, let's try a division problem. Here again, I have it in the shorthand. It saves room. What do we do with 15 and 3? What do we do with 240 and 135? Okay, subtract. Numerator minus denominator. So what's 240 minus 135? Okay, if you don't like shorthand, write it as 5 times cosine 105 plus I sine. Alright, so before I get you to your homework, I want to make sure that you understand everything that's going on here. So I'm going to give you a half sheet of paper. There are 5 problems on them. I would like you to do these and get each one of them checked off with me. You can wait. You can get 1 checked off at a time. You can get 2 checked off at a time. If you want to wait and get all 5 checked at once, that's fine. You can kind of gauge how many people are waiting to talk to me at once. Okay? But I would like you to do these before I give you your homework. Make sure we have the right idea here.